Hi everyone, in this video we're going to talk about a library in Python called PyAutoGUI, and we're going to see how this works and use it in a project, a Dino game, to actually see how it's going on, and if you want to see how this Dino jumps over the cactus, so stick around and keep watching till the end. I'm sure there are tons of videos on PyAutoGUI on YouTube or anywhere else, so we're not going to spend time going over the methods that are available in this library. Instead, we're just going to use the ones that are used in this simple game project. First of all, we import this library. If you don't have it installed, just go right ahead and type pip install PyAutoGUI in your terminal so that you can use it. Okay, the first step here is that we want to use this library to be able to use the space button when we reach a cactus so we can jump over it. In order to be able to do that, we need something like a function to let us do this. We need to locate something on the screen, but it's not necessarily related to the cactus. We'll soon see what I really mean. It's really simple. Locate on the screen. So this function is gets a path from you, a path on your system, and it's meant to be a picture, the path of picture. And we will try, because sometimes you might not have that specific picture on your PC. We'll try and we'll get pg.location on screen, location on screen, this one. We'll pass the path and also something else that we'll just get to it in a minute. It's going to be the location of our picture. So now that we have the location, we can print the location. The output of that would be a box, something like a box, and so it's called location. Sorry. We can then return it because we're gonna use it afterwards. But if that didn't work, it doesn't mean that we need to face an error. We're going to use except, and it's going to be pg that image not found. This one, I guess. Yeah, but this alone won't help you unless you use another line called pg.use, image not found exception. It's going to make this work. Other than that, you're going to face the error unless using this except. Anyways, when we reach this except point, we're going to print something like, for example, cannot locate this path, whatever it is. It doesn't matter. And then we'll return none, just because we don't need anything here. So this one, it'll get the path of a specific image on your screen, and then it will let you know where it's located. So if you want to test it, we're gonna take a screenshot from one of those points here. For example, something like this. This is a picture on my screen. I'm going to save it somewhere on my PC, and yeah, we can probably call it icon. Then we'll save it and we'll see how it works. Locate on the screen, and the path. Of course, I think it's really complicated to find the path right away, so we'll copy the path and we'll give it a function. Hopefully it works. Sorry. And just for your information, this part of my screen should be 0, 0, but if we move vertically, we'll reach this point where x is still 0, but we have y values. So let's go ahead and print what we'll see. Yeah, it says it can't locate this icon. Let me test it with something else. There is another argument in this function called confidence, and it can let you have a little error, for example 96. Okay, and just for your information, if you don't have OpenCV installed, then go ahead and install it, because this argument just works if you have that library installed. So let's try it okay, as you can see, we have all the coordinates here. We've left, top, and then width and height. So with these two we can have also right and down. Now that we've seen the functionality, we're going right into the next function. It's called calc pose. Means it's going to calculate the position of that specific thing, because as you see, it's a box, but we need the x and y coordinates. So very simple, we're going to pass the location thing that we've already created, and also it's a try except part again, because we're going to face the error in this part too. This time we'll use the method center. Center just finds the x and y coordinates. It's not something crazy. And we will return them. In the next part, so let me complete the except part. So it's going to be value error. It's not a big deal, just trust me. Coordinates cannot be negative, okay? The minimum is 0, 0, so if you have -1, -1, it means that something is not right, or we don't have the picture, okay? It's not available, as we saw in the beginning, okay? But another thing, just that we need to get started with the game, we need to be able to click on a specific part of the screen. So this library is capable of doing that too. We're going to have a function called click on image, okay? Image path, as we always need, and something here that sometimes is necessary, timeout. We're going to set it to 1 second just for safety and we don't run out of time. So we're going to test it. Okay, this is for times when your function doesn't capture the image in the first time. So we need to iterate over that to see whether that image really exists on your screen or not. So for doing that, we need time. Okay, we don't have the time module imported. Import time. We save the start time, and then we're going to have a while loop. Start time. If it's greater, if it's less than timeout, we're going to do that again. So this is again a try and error part. We're going to get x and y coordinates, not something very special, just exactly as what we did before, x and y coordinates. And now we're going to use the functions that we have already built. We want the x and y coordinates, so we use calc pose. Then what calc pose needs is the location of that. So we're going to use locate on screen function. And after that, we're going to pass the path of our image. It's image path, as we've defined in the signature of our function. And if it's not okay, we're going to have an except part. But before that, we shouldn't forget to click on it. Of course, PG library has a click method, and we can just pass the center X and center Y. It's going to handle it itself. After that, we are going to return nothing, because nothing is really needed here. Maybe it's not needed. The except part is just a print to let us know that we haven't been capable of clicking on that specific part of the screen. It's, as I said earlier, just for starting a game, nothing else in this project, but it's pretty useful in general. And the next function is a little different. Now we are going to be able to detect all the cactus, but they have different shapes, as you have seen. There might be 3 of them, 2 of them, just 1 of them, and I've gone through this. It's very challenging if you try to detect the trees themselves, because it's going to be such a nightmare. And instead we can just detect the green color, the specific green color in that used in that specific page. So it's going to be very simple, using another library called Pillow, P-I-L, and we'll have it right here from PIL. Import, we only need one of the modules. It's image grab. Where is that? Yeah, here. Oh my god, there were tons of them. Here we go. And our function is capture and check for greens, because we only need greens. And this is going to just get all the values that used in this box. So we're going to have left, top, right, and bottom. Okay. After that, it's not complicated, just taking a screenshot. In this function, we're going to have a screenshot that is taken by image grab, and using this grab method. Here we have bbox that will get all these values here: left, top, right, and bottom. Here we go. This is now complete. When we take the screenshots, if the if that part of the screen contains a green pixel, meaning that, okay, let me show you the game. If there is a green pixel in that part of that a specific area, it means that we are approaching a cactus, so we need to jump. Therefore, we haven't built the function yet, but we're going to call it here. It's called is green pixel present. And we're going to pass the screenshot that we just took. Okay, if it's true, meaning that yay, we have reached the cactus, we need to jump. So we can either use pg.press space or pg.keydown. There's no difference in this case. And our key here is space. So we do that, and for our log we can print it to cactus found here, and if otherwise we can just print no cactus. There we go. Okay, it's time for the last function to be created. It's exactly this one that we have already named, and in this one we're going to pass the image that we took, exactly the screenshot, and we are going to, just for a note here, we're going to iterate through each pixel to find a green one. So it means that the smaller our area is, the faster our for loop would be. For x in range width, and what our width and height would be is this. Width and height would be equal to image.size, the image, the screenshot that we have already taken, dot size. It has a size, of course, and we're going to use these two values. I know it might not be the most optimum way of doing it, but since our area, the screenshot that we take, is not too big, it's going to work without any major problem. The pixel now is the image.getPixel. This is a built-in method, of course, pixel, and we're going to pass x and y values, so to see if the pixel is green. This is the last part that we're going to focus on. This is the pixel, but how are we going to detect whether it's green, blue, yellow, purple, or pink? It's just as simple as possible. First, we're going to check if that is check if the pixel is green. And in this part, as we might see, pixel is a tuple with 3 values. It's representing RGB values: red, green, and blue. So the first one is green. It should be equal to something that we don't really know now. And pixel 1, the second element, should be equal to something else. And also the last one, pixel 2, as well. So what these values should be, this is a question. If that happens, then we have reached the true pixel. Otherwise, of course, this is false. Return false. For this purpose, we right click and we then go to inspect. In this part, we're going to find a color. Now we want the green color. For this, we go right over this green pixel and choose the color. After choosing this, we get the exact hex number. Then we search for it on Google and find the RGB values. The exact values are written here. Then we copy all of them and paste it in our code. We're going to place them here. The first one was 64. The first one, second one is 144, and the last one was 22. So these are the exact values of the green color that we had on that page. And lastly, we're going to click on that image. Of course, what we see here is a game over and something like that. It's up to us what we're going to do, but it's easy to do that. We're just going to take a screenshot of this and then save it exactly in the folder that we have. Here I've saved it. This is the game over icon, and if we like, we can also take a screenshot of that dino, but I think that's just okay for now. So we're going to click on image just to start the game, and it's going to be this one. I've already had the image here. Sorry, copy the path. Yeah, and we're going to have it right there. If that is, it might be unnecessary, but it's just here to make sure that we get started. After that, we can have a while loop that goes on for as many seconds as we like. So I probably like something like 20 seconds to test it. Time. minus t0. Okay, we need to define t0 first and then go on with this. Yep, like this. T0 equals this one, and the last part is to capture a region from a specific part of your screen. This for me is something like this. I'll show you how I found them in a second, but just a minute. X equals 2 and y equals to something like 470. I think these are not the most accurate values, but they're good for now. And we'll put them here, exactly the values that we've chosen. I'm just going to show you how I took them. If you take a screenshot of your picture, you'll see how you can do that. So you can open the paint here, and as you move all, I think, yeah, it's a little complicated here, but if you use your here, what's it called? It's called selection. The selection part, you can use it to see which values you're in. So I think you're not capable to see it right now because it's too high. I think now it might be okay. In this part, on left corner, bottom left, you'll see that as I move this cursor, x and y values are changing. So this area is actually going to be the working area, the operating area for us. So we're going to place the x between something like 150 and 300, something along these lines. But we're not so strict about y values because we're not really sensitive about the vertical values. There's nothing green here, and just we're moving horizontally. As you are observing, the dino doesn't move. Actually, it's stationary, and cactuses are getting closer and closer. Now it's time to run the final project to see whether it works or not. I've designed it to be like this, this one on the left and this one on the right. So make sure to capture all the screenshots in this specific position, because otherwise it might not work for you. And also just feel free to change the value of this confidence argument, because it's just up to you. So now if we run this project, it should work. Okay everyone, I hope you've enjoyed this video and you're able to use this one whenever you want. Just let me know if you have any questions or ideas that you want to share, and thank you for being with me till this moment.